Welcome to another lesson in the Designing VMware Infrastructure video training series. In this lesson, we're going to be talking about specifying backup and availability in your logical design. In this lesson, we're first going to take a look at what are the backup and availability needs. What do we have to include when we talk about specifying backup and availability? And are there any ways we can categorize how we provide backup and availability in a design? We'll then look at some specific solutions, and I'll explain why, even though we're still talking about logical designs, we're going to look at specific solutions. From there, we'll move into identifying backup and availability requirements, and then evaluating solutions based on those requirements. We'll round out this section with a look at reviewing your related areas that are affected by backup and availability, and then look at another tool for analyzing design impact, helping us to understand and further enhance our view of the design in a holistic fashion and understanding and exploring relationships between components within the design. Before we get into the lesson, I first want to review some key terms. Again, RPO and RTO, or Recovery Point Objective and Recovery Time Objective, are terms that I have introduced to you already in this course. Just as a quick review, the recovery point objective is a measure of how much data loss, if any, the environment's allowed to sustain. So if you are doing backups every 4 hours, then you have a 4-hour RPO, because at most you will lose 4 hours worth of data. Your RTO is how long it takes to recover the environment. So if it takes 4 hours to restore a backup, then your RTO is 4 hours. Business continuity and disaster recovery are two terms that are often used together, but they are separate and distinct, although related. Business continuity talks about those activities that are involved in how the business continues to operate in the event of some sort of significant outage. It may be operating in a reduced capacity, but it is still operating. Disaster recovery, on the other hand, is more applicable to the activities that surround or involve how the business recovers from that outage. So business continuity talks about how we continue to provide our services while we're in the midst of an outage. Disaster recovery talks about how we recover from that outage back to full service again. We'll be using these terms periodically throughout the remainder of this section, so I wanted to make sure that we have a good understanding of them before continuing. So what do we need to include when we talk about backup and availability and specifying backup and availability in our logical design? At a broad level, we can basically categorize backup and availability into 4 buckets or 4 areas. We can talk about the actual backups themselves, or to bring some consistency to our terminology, we can talk about data availability. How do we ensure that we have the data available in the event of something happening? We can also talk about application availability. How do we ensure that applications are accessible across the network and that they are functioning and working and providing the services that end users expect them to provide? We can talk about VM availability, which, although related to application availability, is separate and distinct. We can also talk about site availability. How do we ensure that an entire site can be kept up, or if that site goes away, how do we carry on from there? Each of these 4 broad areas both affects and is affected by your RPO/RTO requirements. Now, these RPO/RTO requirements were created and generated by you, the architect, as part of the requirements analysis process that I've discussed in other sections of this course. So having that information available to you now, where you have defined RPOs and RTOs, and we'll look at an example of that later on in this section, that helps drive which of these areas is affected and how they're affected by those requirements. In order to specify backup and availability in our logical design, we have to have a good understanding of what sort of solutions we can use to meet the requirements or the needs that I've just discussed. The needs being, backup or data availability, application availability, VM availability, site availability. And so what we have here are some solutions that you could plug into the logical design. Now you might be wondering why, even though we are still talking logical design here, I have listed for you some specific solutions. Generally in a logical design, it's high level. We don't talk solutions, we don't talk specific products, we talk about requirements, we talk about needs, we talk about what the design has to accomplish, not necessarily how the design goes about accomplishing that. But in this particular case, and a couple other areas in the logical design process, the requirements themselves are the high level design. And so when we get to the point when we are ready to round out the logical design with backup and availability items, we've already got the high level piece in the requirements in the design factors. Now it's time to actually take that down one more level, and then we'll take it down one more level again when we get into doing the physical design, which we'll discuss in other sections in this course. So at this point, we've already created some high level designs in the design factors, and I'm going to review those with you in just a moment. And in order to address what the logical design is going to do, then we now need to plug in some specific solutions. And so when we look at backup solutions, we have a couple of different options here. We have in-guest backups, hypervisor level backups, array-based backups. Each of these solutions has its own advantages and disadvantages, and it will be up to you as the architect to understand, as we have discussed throughout this course, how those advantages and disadvantages play with the design factors, how they affect other areas of the design, and how you can choose the best one. When it comes to availability, there are again a number of options. We could rely on vSphere HA or vSphere FT. We can rely on application level or OS level clustering, host-based or array-based data replication solutions, or even a tool from VMware like Site Recovery Manager, which provides workflow for moving workloads between one site or another. All of these are potential solutions that you can plug into your logical design to satisfy the high-level requirements. Since we're going to be taking items and plugging them in to satisfy requirements, design factors that specify what we need to do with regard to backup and availability, let's take a look at some requirements, and then from these requirements determine which of these requirements are going to need or to generate backup and availability solutions. These requirements are taken from the Cloud Infrastructure Architecture case study. That's the VMware document that I've shared with you in a variety of lessons in this course. And in this table, we can spot a couple of requirements that will affect the backup and availability specifications in the logical design. For example, notice requirement R102 that says availability of services is defined as 99.9% during core business hours. That is an availability requirement. It has the word availability in it. So it clearly tells us that when we go to designing availability for the logical design, we need to account for this specific requirement. Looking on through here a little more, we see R108, the recovery time objective, or RTO, in the case of data store failure should be less than 8 hours. So here is a backup and availability requirement, more specifically a backup requirement that says if we have to restore a data store, if we have to recover a data store, note that they're using RTO, recovery time objective, then that metric that we're shooting for needs to be less than 8 hours. Both of these are requirements that we have picked out of the list of design factors that were generated during the requirements analysis process that are going to have an impact on the backup and availability specifications in your logical design. So we've looked at requirements. We've talked about requirements in a number of different places throughout this course, and we'll continue to discuss them in a number of places throughout this course because they drive everything that we do in the design. And we've talked about solutions that are available to help satisfy those. How do we choose which solution is the best one to meet the requirement? Well, that's going to be all driven by the design factors. It's going to be driven by the requirements itself. It's going to be driven by constraints, risks, and assumptions. Now, you should have already gone through a discovery process where you have analyzed the environment, assessed the environment, performed your requirements analysis, and generated your design factors. And out of those design factors, you will have generated a list of requirements similar to the ones that I just showed you that define the data protection and availability needs of the environment. Those are your high-level logical design. Unlike compute design or storage design, where we can have a high level and then a more detailed lower level design, the high level design for backup and availability is actually in the requirements because the requirements specify this is what it's going to do. Now as we move into a more specific, we begin to plug solutions into that. And the solutions need to be plugged in based on how they satisfy the design factors. So the design factors will lead you to the best and most appropriate solution for this particular design. Many of the needs are summarized in your RPO, RTO values. And as you plug solutions into your logical design for backup and availability, you will want to consider the design impact of each solution. You'll need to evaluate that and ensure that the design impact of this particular solution does not generate problems or risks in other areas. Now let's take a look at an example of a design requirement and how we would go about evaluating solutions to help satisfy that requirement. This quote is one you'll probably recognize. It's taken from the table that I showed you just a few moments ago from the Cloud Infrastructure Architecture case study. It's an availability requirement that says availability of services is defined as 99.9% during core business hours. So this is a requirement. This is a design factor that has been generated from the requirements analysis process. And now we need to determine what solutions can we use, what solutions should we use to satisfy this requirement in our design. Let's delve into this in a little more detail. So what does it mean when it says availability of services must be 99.9%? Well, that means that we're allowed basically 9 hours a day, or 2,340 hours a year, the total amount of core business hours, and of that we have an RTO of less than 2.34 hours. That's 0.1% because we are saying that there has to be 99.9% available. With that in mind, once we've crunched the numbers and understand what our availability requirements are, then we can begin looking at solutions that would satisfy that. So could we use vSphere HA, for example, to ensure that availability is at 99.9% during core business hours? We know that vSphere HA addresses hardware failures and that generally workloads will restart in a matter of minutes. Is that enough to satisfy this requirement? Do we need to step up to something like vSphere FT, where mirrored VMs run on separate hosts and there is very little downtime, if any at all, when a failure occurs? Or do we need to look at application level or OS level clustering? Each of these potential solutions has its own set of impacts on the rest of the design, its own set of requirements. If we're going to use vSphere FT, for example, then that's going to impact our virtual network design and our logical network design because we have to account for the FT logging traffic. If we're going to use OS level clustering, that's going to affect our storage design. That's going to affect our VM design. It's going to affect our network design. And so we have to understand the impacts of each of these and include an analysis of the impacts as we evaluate solutions against the requirements to determine which solution will meet the requirements best. In reviewing the relationships and impacts, it's helpful at times to use some sort of diagram like a mind map shown here to help map out or uncover relationships between different components. I've shared this with you in other lessons in this course, and we'll revisit it again here to help us continue to reinforce our view of the design as everything being inherently interconnected. So we know that as we look at the core of this section in terms of backup and availability, that it has reaches into a variety of different areas. So we look at the RPO, RTO aspect of backup and availability, or we look at the application aspect, or we look at site availability aspect. Each of these is going to affect a number of areas. If we consider site availability, for example, we know that's going to affect our operational processes. It's going to affect financial constraints. It's going to affect licensing. It's going to affect the physical network design. So decisions that we make in the site availability area are going to have impacts in these other areas. Now, this sort of diagram that I've shown you in a number of places and that we've just walked through again is great for uncovering relationships, but it doesn't necessarily tell you what impact occurs as a result of that relationship. What I'd like to do now is show you another way to track and explore and monitor and analyze the actual impact that occurs from design decisions. Here we're going to use a tabular format, a table. I created this table in a spreadsheet application, did a little formatting to make it look nice here, but certainly you don't have to do that. You just need something to keep track of rows and columns. You could do it in a Word document, you can do it in a spreadsheet such as Excel or others. And what we have here in this particular case are 3 columns. You might add more columns, but at the basics, here we have 3 columns. And in each column, we have first the design decision, a particular design decision that says this is what the design is going to do. Then we have, for the sake of brevity, a single design impact. Now, when you do this analysis in a tabular format, you will likely end up with multiple design impacts. For brevity and just for the sake of keeping this short, I limited this particular analysis to a single design impact. And then also showing here are risks. Does this particular design decision introduce risks in other areas of the environment? And each of these are arranged in a row so that you can track which design decision has which design impact, which creates which risks. So if we look at a couple examples here, for example, let's look at the third one down. It says vSphere HA will be the primary mechanism for protecting VMs against hardware failure. That's a very common design decision. Nothing wrong with that design decision, but what is the impact of that design decision? One potential impact is that all VMs that are going to be protected by vSphere HA must be stored on shared storage. Okay, that's fine. That helps us understand that we can't use local storage, for example, if we're going to use vSphere HA, which may have a variety of ripple effects or ripple impacts because we have to use shared storage. And this is why when you do this analysis on your own, you will probably have multiple design impacts because we can carry these multiple levels. Does it introduce a risk? Well, vSphere HA alone can't protect against application or service level outages. It looks at a hardware failure. So if our RPO, RTO, or SLA, our service level agreement, says that applications must have a certain uptime or certain availability, then vSphere HA may not be the best solution to meet those requirements. We may need to look at an application level clustering type solution. Let's look at another example. The very next one, Array-Based Replication and Site Recovery Manager will provide disaster recovery or DR protection. What is a potential design impact from that? Well, I'm going to have VMs that have similar SLAs, RPOs, RTOs. They have to be grouped by data store because array-based replication typically will replicate at the level of a data store. That's its granularity. So if I have some VMs that need an RPO, RTO of, let's say, 2 hours and some that have an RPO, RTO of 8 hours, I would need to separate them according to that RPO, RTO, or SLA. What that means is, as a potential risk, is that we're going to introduce some inefficiency into the design because we're going to have to artificially break VMs up when it may have made more sense from an efficiency or storage efficiency perspective to put them together. This is, again, a fairly simplistic way of looking at this data, but it does give you an idea of how you could use a tabular framework to show the relationships between a design decision, one or more design impacts from that decision, and one or more design risks that may be introduced as a result of that decision. And you could add additional columns to show second level design impacts or benefits to the design or anything else of that nature. This is, again, just one more example of how you can use a variety of tools to help explore and map and maintain an understanding of the relationships and impacts among the various components in the design. As we wrap up this lesson on specifying backup and availability in the logical design, let's quickly review what we went over. We first started out with examining the backup and availability needs. How do we define backup and availability, and are there some broad buckets that we can use to describe the features that need to be specified in the logical design based on the design factors? We then moved into looking at some potential solutions that we could plug in to help satisfy those design factors. After that, we looked at how we could go through the requirements or design factors that we created as a result of the analysis and assessment process and identify which of those help or specify backup and availability needs. We then looked at evaluating solutions based on those requirements, determining which solution would be best suited for a particular need, and reminded ourselves once more that we have to be sure to consider design impact. And speaking of design impact, we then moved into a review of relationships between different areas and how some areas can affect others. And then I introduced you to the idea of using a table like a spreadsheet to analyze design impact and track what impacts result from what design decisions. That's all for this lesson. Thanks for watching.